Hello, this is Mr. Ezra. In the last video, we talked about how to solve quadratics when the leading coefficient, which we call a, is greater than 1. And the process took up quite a bit of space. We used some tables and some space under some tables, and it just took up a lot of room. And I wanted to take a quick minute or two here to show you how to kind of condense those steps into what I'm going to call short steps. So that you're not writing so much, that you're not doing so much work, but you're still following the same procedure. I'm only going to do one example here. We're going to look at 10x squared plus 7x minus 12 equals 0. So instead of kind of writing it out the way I did in the table, what I'm going to do is I'm just going to use a t-chart to find the factors of 10. And in this case, 10 is not prime. So the examples we saw in the last video, all of our a's were prime. This is an example where it's not prime. So one possibility is we could have 10 and 1 as the factors of 10. The other possibility is it could be that we would use 5 and 2. So either 10 and 1 or 5 and 2. Negative 12, we have to think about that as we're finding factors of it. What multiplies to give you a negative must be one positive number and one negative number. So I'm just going to put the negative numbers first. So I know 1 times negative 12 is negative 12. I know 2 goes into 12 6 times, so I'll use negative 6 and 2. And I know 3 goes into 12 4 times, so I'm going to use 3 and negative 4. Well, that's great. Could be 10 and 1 and any of these combinations. So I'm just going to kind of come down and write 10 1, 10 1 so I can see it there. Remember that once we do this process, if we get an answer that is negative 7, our goal is the B term, this the positive 7 here. If we get a negative 7, we just have to switch the negative to the other number, and that's fine. So these three factors of negative 12, I'm going to put with 10 and 1 and with 5 and 2. So I've written kind of the same information that I did a minute ago, but it's not going to take up as much space on the paper. I can condense it down into two tables, two T-charts. Don't take up a lot of room. Now, off to the side here, I know some of you are going to want to do this in your head, but I want to keep up with what I'm doing. Out to the side here, I'm going to be multiplying the outside numbers together and multiplying the inside numbers together and then finding the sum. So this O plus I have written over here is just an indication that we're going to find the product of the outside plus the product of the inside. In the FOIL process, it's the O and the I. So I've highlighted that so that you can see that I'm staying to the outside. 10 times 1 is 10. See, I'm not going to write it all out. I'm just going to actually go ahead and multiply. And then 1 times negative 12 is negative 12. My goal is 7. If I don't get 7, I got it wrong. And negative 2 is not 7, so I go to the next one. Outside, 10 times 2, that's 20. Inside, 1 times negative 6 is negative 6. And that is 14. 14 is not correct. Not going to work. So 10 times 3 is 30. 1 times negative 4 is negative 4. This time we got 26. So we can see that none of the combinations work with 10 and 1. So 10 and 1, kind of put a dashed line there. 10 and 1, none of those work. I'm going to move on to 5 and 2 and see if one of those work. Now, we haven't seen this, and we probably won't see this for a little while, but it is possible that this is non-factorable. And in that case, we would just, at this point, write non-factorable. But this is going to factor. I think one of these combinations is going to work. So outside times outside is 5. 2 times negative 12 is negative 24. And 5 minus 24 is negative 19. I'm still not there because my goal is 7 and I haven't got there yet. 5 times 2 is 10. 2 times negative 6 is negative 12. Negative 2 is not going to work. I'm looking for 7. I've only got one possible combination left, so let's try it. 5 times 3 is 15. 2 times negative 4 is negative 8. And 15 plus negative 8 is positive 7. And I am looking for a positive 7. This is the winner chicken dinner right here. It's just the goal that I want is 7. I've got 7. So I want to make sure that when I do this, I'm going to use these when I break apart my parentheses. Now remember, the factors of a go first. So in my parentheses, I'm going to use 5x and 2x. Those are the factors of 10 with an x added on for the x squared. And then the other two, the factors of negative 12 that worked, are going to be at the end, minus 4 and plus 3. And I've been using the zero product property, setting 5x minus 4 equal to 0 and 2x plus 3 equal to 0 and solving. But since we're doing shortcuts here, I'm actually just going to come down and use that rule that I talked about, that kind of shortcut step where we just say opposite of the constant over the coefficient. So the opposite of negative 4 is positive 4 over 5. 4/5 is one of the roots. Opposite of positive 3 is negative 3 over 2. Negative 3 over 2 is my other root. And you can see that, I've kind of written a bit here, but this is a little bit more concise. And some of this work I could do in a calculator in my head and even not have to write it out. But I do want to make sure that my outside and inside products add together to give me that middle term. And I've done that here. I can circle it, and I'm confident that I got the right answer. Well, thanks for tuning in. This is just a little short, quick added video to the solving quadratic equations when a is greater than 1. Hope that it helps you out, help you to tighten up what you were doing. I'll see you in class.